Okay, now, so what we have in front of us is a vector field. It has two components. First component, 2x y to the fourth plus 5 e to the 5x. Second component is 4x squared y cubed. So we want to find out, is this a conservative vector field? And so we're going to take that test we just learned and put it to use in this first case where we don't know at the beginning if this is a conservative vector field or not. Let me just make a little bit more space for writing in. And so here is the idea. Don't just show the pieces of math. Put in some of the thoughts and words so that it's really easy for somebody who's just sort of catching up to follow, what's going on the screen. So I'm going to just sort of ask this question: is capital F vector field conservative? All right, that's the question I'm starting with here. I'm going to try to answer that question. And another thing that goes with that then is, well, what's the test to find that out? Well, we just discovered that means we want to find out, is the first component's y derivative equivalent to the second component's x derivative? All right, so we're asking, is this a conservative vector field? And we're saying, okay, here's what I mean by that. And just a quick little reminder to you so that you guys don't get overly lost here. This vector field that you see up above, the first component here, that's your M. That doesn't look like a very good M. That's the first component. Let's try this one. So that's your M. And this is your N, your second component. And we're trying to determine, if we take the first component's x derivative, does that match the second component's y derivative? So we're going to go through and do that check down here. All right, oops, one off the screen. There we go. So the first component's y derivative, we have a term that has only x's in it. That's going to be derivative, that's going to be 0 because y is the variable. But then we have this right here. So its derivative is going to be 4 times 2 is 8. 8 times x times y to the third power. And then we'll repeat that over here and say, well, what's going on this side if we do its x derivative? Well, 2 times 4 is 8. And so that's going to be 8. X is not going to be to the first power, but the constant y cubed is still there. And lo and behold, both of these sides are equivalent to each other. They are both the same. Check. They are equivalent to each other. So now, check mark is not an answer. It's not words. It's mostly telling your brain that you've looked for something. So what our conclusion is that, therefore, F, the vector field, is conservative. Now, we're not going to go into great detail here yet, but if this problem looks slightly familiar to you, it's because this is the first vector field we made. In the video number 1, we took the gradient of a function and it gave birth to this vector field right here. And that function, f of xy, was equal to x squared y to the fourth plus e to the 5x power. And if you recall, what this meant for us is that this particular function is then called the potential function. That question wasn't asked here. Question was asked is the vector field conservative? Later we're going to try to find out how do we determine what that potential function is. So stay tuned for more.